Good morning, Lexi. I wanted to go ahead and get some of these proofs done with you. We're going to go ahead and look at lesson 51, number 23 first. And I gave you these sheets, so you might want to go ahead and pull those out and have those ready. I'm going to do one at a time, so I'm going to send a video for 51, number 23, and then I'll send a separate video for 24, and then you can watch them as needed. Okay, so let's look at 23. 23, you see this shape, it's a triangle, and within this triangle, you see 3 additional triangles built inside of it, all connecting at point P, somewhere in the center of the larger triangle. What we know here, first of all, we want to use what's called the indirect method. And lesson 47 talked about that indirect method because sometimes we don't have enough information to actually use the proofs as we've been doing them, where we can deductively reason through based on what's been given to us. We have enough information to make a proof statement. However, sometimes they give information about our shape that doesn't actually give enough information to work through it deductively. So that's when you'll use an indirect method. So for example, in our given statement here, we're told that ABC is not an isosceles triangle. So we'll go ahead and fill that part in right here. So ABC is not isosceles. So look what we're trying to prove here. We do see that angles 1 and 2 are congruent, so we can go ahead and mark those, that those are congruent. We'll just kind of put those little arcs on them with a little tick mark. That's all we know right now. We know that ABC is not isosceles, so that means that I can't even pair up any sides. You know, if it's an isosceles triangle, we know that there's going to be 2 sides that are going to be congruent, right? But in this case, I don't even know, I can't pair any of the sides up because it's not an isosceles. So all I really know is that I have angles 1 and 2 that are congruent. Now, we always know that when we see more than one triangle in a triangle, we're probably looking to prove some triangles congruent. Okay, so the indirect method says, let's do this. Well, first of all, let me go back a minute. So we're saying in the proof statement, because that's where I was headed, we're trying to say that APC, right here, APC is not an isosceles triangle. It looks isosceles to me, but they're saying it's not. So we need to prove that. Since we don't have enough information to do that, then we need to use this indirect method, which basically says that, hold on, let me get my answer keys over here. Okay, that basically says what we look at in number 2, that either APC is not isosceles, which is what we're trying to prove, or it is. So you're kind of looking at it like, well, I guess if I'm going to prove the opposite of this proof statement. And if I can prove the opposite of that proof statement, then it should end up contradicting what's given. And what's given has to be true, because what's given is what's true about the shape. Okay, so we can't ever change what's obviously given for our information, but we're going to work through this proof so that we can find a contradiction in the given statement. Then that will prove that APC, that smaller triangle that I marked in yellow, is not an isosceles. So on number 2, either APC is not isosceles or it is isosceles. So we're going to assume that it is isosceles. So we're going to go against what we're trying to prove to show a contradiction in the given statement. So a statement is either true or false. Number 3, if APC is isosceles, then AP would be congruent to PC. And that would just be definition. Actually, it comes out of your packet that I gave you. Definition 31 states that an isosceles, and I'm going to do some abbreviating here, an isosceles triangle has 2 congruent sides. Okay, angle 1 and angle 2 are also congruent, but that was given to us, so we can put over here in 4 that was given. Also, now look at where we're kind of headed with this. Looks like we're headed to show that, I'm going to highlight these in a different color, but it looks like we're trying to show these 2 triangles congruent, because notice what has happened so far. I have two congruent sides and two congruent angles. If I can prove another side or another angle, then I could figure out with those three parts of corresponding congruent sides or angles that I have two congruent triangles. So you love the reflexive property. You usually can identify that when we're together. So we're going to say that we see that that side and those pink triangles is shared by each one. So PB is equal to PB due to the reflexive property. Now we have enough to say we have two congruent triangles. Those two pink triangles show corresponding sides. There's two sides that are congruent with each other and one set of angles. So based on side, angle, side, we have two congruent triangles. All right, now if those two triangles are congruent, then that means that these outer sides, I'll have to put 4 tick marks on this one, are congruent, right? Because remember, if you can prove two triangles congruent to each other, then all their corresponding parts are congruent. So AB and BC would be congruent. This side that I just marked and this side that I just marked. And you should go ahead and be marking up your figure as mine is as well. Okay, so we're going to write that down. AB and BC is congruent to each other. Actually, it's in step number 7, based on the congruent parts of congruent triangles are congruent. That's that CPCTC. All right, now look back. If AB and BC are congruent, and I'm going to erase all this stuff for a moment because I want to show you here what has happened. So if AB and BC are congruent, look what that tells us about this big triangle. That proves that we've just shown, based on the route that we took, we have shown that we have an isosceles triangle because we have two sides congruent in that large pink triangle. So ABC is an isosceles triangle. So we'll write that in here in step number 8. Triangle ABC is isosceles, okay, based on that step number 7. The definition of an isosceles triangle is how we can state that. It has two congruent sides, so it is an isosceles triangle. However, let's look back up here. So we just said ABC is isosceles, but look at what was given. ABC is not isosceles. So through this indirect proof, we find a contradiction to the given information. So what we decided to say was true, assume APC is isosceles right here, can't be true. So we have to say that APC, which is what we were trying to prove here, APC is not isosceles. That smaller triangle there is not isosceles because we just changed what the given information said, and that's not true. So in statement number 9, the reason is because it contradicts the given statement, and we cannot contradict the given statement. So statement 8 contradicts the given statement that triangle ABC is not isosceles. The assumption that we made in step 2 must be false. So by elimination, statement number 9 must be true. Okay, so that is how we do number 23 in lesson 51. And I'm going to go ahead and close out here, and then I'll come back and do the second video for you in a few minutes. You can pull it up. All right, thanks for